Example 8.5 says solve the given system by the substitution method. And this particular system is set up pretty nicely. If I look at equation number 1, I'll notice that it already has x equals 9 minus 2y. So I should be able to just directly substitute that in for the x in the second equation. So my second equation is now going to turn into 9 minus 2y plus 2y is equal to 13. So nothing to distribute, but I do want to combine like terms. And if I combine like terms, we'll notice that the minus 2y and the plus 2y end up canceling out. So then I have the statement 9 equals 13. And that's a false statement. So something's going on here. So when we talked about linear systems, we talked about 3 types of system. We talked about the intersecting lines case, just 2 lines that cross, have 1 point that counts as the solution. We talked about parallel lines, lines that never cross, would have no solution. And then we also talked about the same lines case, where it's just 2 of the exact same line, one on top of the other. So when we get the variables to cancel out like they have here, it means that we must be in one of these 2 situations, where it's either parallel or the exact same line. Now, in order for us to verify which one it is, since this is our first time seeing it, we would want to check this by taking the equations and trying to write them in the mx plus b form, because we know they're linear. So here's how we're going to check things. So it's a slightly different way of checking than we've had so far. So equation number 1 is x equals 9 minus 2y. Let's solve this thing for y. So I'm going to subtract 9. X minus 9 is equal to negative 2y. Divide by negative 2 to get negative 1/2 x plus 9/2 is equal to y. Do the same thing for equation 2. We're going to take x plus 2y equals 13. Solve it for y by subtracting x on both sides. So 2y will equal negative x plus 13. And then divide by 2 to get y equals negative 1/2 x plus 13/2. So once we get them into their respective mx plus b forms, we can see that they have the same slope, but they have different y-intercepts. So they're not the exact same line, but instead they're parallel lines. So this is a way for us to see, since this is the first time having this occur, what do we do to interpret getting a false statement whenever the variable completely cancels out. So this is to be concluded that we have parallel lines, and we're asked to solve the system though, not state the geometry of the system. So we would need to say then, no solution. Or if you prefer to use the empty set notation, you can also say that as well.